Today we're going to take a look at finding relative extrema of multivariable functions. Multivariable meaning f of x comma y, two variables. They can be a and b, r and t, whatever letters you want. And this is what's called using the DTest. We have our original function up here, and we're going to find the partial derivatives. So we're going to find the first order partial derivative with respect to x of the first term. You get 3y. From the second term, you get minus 3x squared. And from that third term, you don't get anything because it's a 0, because y is a number. A derivative of a number is just 0. So let's go ahead now and take a look at the second order partial derivative with respect to x. So we come back to here again, and y is just a number still on this one. And so the first term, 3y, the derivative is 0. The second term gives us negative 6x. Now let's do the second order partial derivative with respect to y. Now x is a number. So when we come back over to here again, we're going to do the first term. With respect to y, we get a 3. And with respect to the second term, we get, with respect to y, x is a number, just 0. Now let's do the partial order derivative with respect to y. We go back up here to the beginning again. The first term with respect to y is 3x. Second term with respect to y is 0 because x is a number. And then the third term is going to give you minus 3y squared. Now we're going to do the second order, so f sub y, and on this x is just a number. When you do that, and we come from over here on this side here, the first term, 3x, is just a number. The derivative is 0. The second term gives you negative 6y. Now we're going to do the partial. And when we do that, we come back over here again. And the first term with respect to x, so y is a number, this first term gives us a 3. And that second term here, because y is a number, is just 0. And notice our second order partials do match. So this is just collecting all of our information. We have our original function here still, our second order partial derivatives. The next step we're going to do is solve the system of those first derivatives equal to 0. So we're going to take f sub x and set it equal to 0. And then we're going to take the f sub y and set that equal to 0 too. I'm moving over here so we have room. Let's solve this one on the right, on the left-hand side rather, for x. Divide by 3. And then we're going to substitute that up in here. This is solving systems by substitution. And so we get 3y minus 3 times whatever we're substituting is equal to 0. And what we're substituting in there is y squared. Let's go ahead and distribute that. Y to the second times 2 is 4. We're trying to solve this equation. We're going to factor out a GCF, which is 3y, 1 minus y cubed. Now we have the difference of 2 cubes over here. And the difference of 2 cubes, we have a formula for that from algebra. And so we have 1 minus y. And it is times 1 minus y plus y squared. That's by the difference of 2 cubes. Let's go ahead and rearrange that because we love to have that square term first, just so we can take a better look at factoring it. Now, we look at that, it doesn't factor. Let's try the quadratic formula. A equals 1, b equals negative 1, c equals 1. b squared minus 4ac, we're testing the radicand, what goes inside the radical. B squared, negative 1 squared is 1, minus 4 times 1 times 1. 1 minus 4, negative 3. Uh-oh, that's less than 0. So in the quadratic formula, what that means is you're getting negative b plus or minus the square root of, and you got a negative number in here. So what that means is no real solution. So that particular part of our factorization, we get no roots from that. We are going to get one from each of these. 3y equals 0, so y equals 0. and 1 minus y equals 0, so y equals 1. That gives us two candidate points. One where you have a 0 and one where you have a 1 for y. Now we do have to go back and find those x values. From above, we have x equals y squared, that's right here. And put a 0 in for the y and square it, you get 0. Put a 1 in for the y, we're down here, and square it, and you get a 1. So our candidate points are sitting right here. Now that we've got those candidate points 0, 0, and 1, 1 as critical points to test to see if they're relative extrema or a saddle point, we are going to have to use the DTest. Now this DTest is using those second order derivatives and the mixed partial derivative as well. And so that's why they're written up here for you. We are going to have to test each of these values here. And so let's go ahead. F sub x is equal to negative 6x. So negative 6, x is 0 here, because this is x, this is y. So we get 0. F sub y is negative 6y. Y is 0. So we get a 0. F sub xy is 3. Now we can do our d-test, and this is the d-test for 0, 0. F sub xx, 0, f sub yy, 0, minus f sub xy, 3, and square that. So you get 0 minus 9, which is negative 9. That is less than 0, so that means we have a saddle point here at 0, 0. Next, we come over and do d-test for 1, 1. So we need f sub xx, again, negative 6 times whatever the x is, which is 1. Gets negative 6. Sorry, that's a little sloppy. F sub yy is negative 6 times y, which is 1, so negative 6. The f sub xy is still 3. So we can go ahead and find that d value. D is equal to negative 6 times negative 6 minus, sorry, I have something in the way, minus the quantity 3 squared. So d is equal to 36 minus 9. D is equal to 27. Well, 27 is greater than 0. And because it's greater than 0, now we have to test the second order partial derivative. For us, that was equal to negative 6, which is less than 0. What that means, less than 0, is that this curve does this, and it's a max. So we have a relative max over here. Well, that's how you use the d-test on those two values. So gathering our information together over here, we've got at 0, 0 a saddle point, at 1, 1 a relative maximum. But remember, we've got a multivariable function of x and y, which means this thing is really equal to z. And so we have to substitute in our 0, 0 into the original function. So we get, and now we're going to come down here and actually find f of 0, 0. And so we've got 3 times x times y, 3 times 0, 0 is 0. Minus x cubed, which is minus 0 cubed, is 0. Minus y cubed, which is 0. So we get 0. That's the point, 0, 0, 0. And we know there is a saddle point there. So there is a saddle point at 0, 0, 0. Now what happens at 1, 1? We're going to substitute it back up into this original equation again. 3 times 1 times 1 is 3. Minus 1 cubed is 1. Minus 1 cubed is 1. So we have 3 minus 2, which is 1. So we have this guy. And we were just testing that point. We were finding the z value. So that means we also have a relative maximum at 1, 1, 1. I know this was really quick. The steps are always the same. You're going to find the partial derivatives. Just go ahead and find all of them. Solve your system of first order partial derivatives equal to 0 and find those critical points. Once you find them, you got to test the critical values at D. So you go ahead and run the numbers through there and then use the d-test to tell you whether you have relative max or min saddle points or no conclusion. Then go ahead and find the z value. Remember, because it's x and y's here, the third variable is a z because we're in 3 dimensions. So you go ahead and find that. You get an order triple, and then just name it. You always need a conclusion. No, you don't have to usually show all your work for finding that third value, but you do have to find it, and you do need to have a final conclusion. So that's it. I hope you're having a great day.